Welcome back to Math for Technology. We are moving on to section 3.5, geometric solids. We are skipping section 3.4. So in this section we are going to be finding the lateral area, the total surface area, and the volume, and we are moving into the idea of geometric solids or three-dimensional shapes. So in the picture that you have in front of you, you can see we have cylinders, which is the idea of we take whatever the shape is and move it straight up, though it can be slightly tilted. We can do that in a circular form, or we can do it in a polygon form. If it's in a polygon form, it's a prism. If it's in a circular form, it's a cylinder. We could come to a point. If it's a circular form that comes to a point, or a curved form that comes to a point, then we call it a cone. And if it is a polygon that comes to a point, then it is a type of pyramid. We also have the idea of a frustum, and as you can see by the pictures in front of you, what you do is you take either a cone or a pyramid and you essentially cut off the top of it, and then what's left, you have two bases. You have a smaller base and a larger base, and that is the frustum. Here we have a chart of all the formulas that are used. Definitely want to have this chart when you're taking your test or doing your assignment, so that you can just look at the formulas and be able to use them. That is the key to this section, is can I take a formula and apply it and recognize which shape I'm supposed to be working with. We're going to go ahead and do these three things: lateral area, total surface area, and volume on the different shapes. Before we get going, we need to make sure we understand the difference between lateral area and total surface area. The term lateral means side, and so the lateral area of any shape is the outer edge of the shape. So if you can think about a soup can, the label on a soup can is the lateral area of that cylinder. And so if you were to remove the label, the piece that you would be holding on to is the lateral area, versus the total surface area is the actual aluminum that has created the can that your soup is in. So the can not only has the outer edge, the side, it also has the two circles that form the top and the bottom. So the total surface area is the side plus the top and the bottom, versus the lateral area is simply the side or where the label is attached. Now that is compared to the volume. Volume is how much can you fill it with? How much soup is in the container? How much concrete does it take to make up that three-dimensional sidewalk, which is a prism? So our first shape we have here, we have a polygon that has gone straight up, so we have a prism. Our base happens to be a triangle. So we're going to go up, and actually on this one, we are going to be finding the lateral surface area. Now I'm not going to do all three of them on every shape because that takes too much time. I'm going to do one thing on each shape. So lateral surface area of this shape is the side, so I have this one that's in the front. I have this one that's over here. And then I have the one that's sitting behind that, let's see if I can do it with a different color. Oops, that is not a different color. So you have the piece that's sitting in the back that is flat. So to find the lateral surface area of this, we're going to go back up to our chart. So we've already determined it's a prism because it's a polygon that goes straight up. And in order to do lateral area, it says to do the P, which is the perimeter, and you multiply it by the height. So perimeter times the height. So the perimeter is the perimeter of the base. So if I look at this base, it is 78 by 140, and on the back side here is the same as the 196. So my P, which is the perimeter, is 78 plus 140 plus 196. So that's 414. The height of this shape is the 235. So I take the perimeter times the height to find the lateral area. So 414 times 235 is 97,290 millimeters. Now, in order to determine what I would exponent this should be, am I filling a two-dimensional object or a three-dimensional object? Really what I'm doing is I'm wrapping the outer edge of this shape. So I'm filling these two-dimensional spots. Since I'm filling the two-dimensional spots, it's only millimeters squared for my answer. Notice I did not do anything with the area of the top or the bottom because I only did the outer edge. So here I have a cone, it's just flipped upside down. Let's find the total surface area on this one. Now notice we always have to start by identifying the shape. So we have a cone, and I'm doing total surface area, so I'm doing pi r parenthesis r plus s. So I'm going to come back down and write the formula. Pi r times r plus s. So we got to figure out what do these letters stand for. Well, r is the radius in both cases. S is the slant height. Now anytime if you didn't know any of these, you would have to figure out how to do it. You would use the information that we've used previously in this chapter. You might have to use the Pythagorean theorem, or you might have to use Heron's formula or area of a triangle, area of a square, those kind of things. We do know pi, it's a number. R is our radius of the circle, which is 5 inches. So pi times 5 times 5 plus the slant height, which is 13. So this is the slant height right here, because it is slanted compared to the straight up and down height, which would be that. So this is H, this is S. So 5 plus 13. So I'm going to take pi. Remember that I would like you to use the pi button, not 3.14. So pi times 5 times 18. So I have approximately 282.7. This is in inches. And again, I'm doing area. So what I've just found is I found all of this wrapped up around the outside of a cone, plus I've done the flat area on the top. But I'm just doing area. I'm not filling the cone, I'm wrapping it up like a present. This next one I can see has two flat areas on the top and the bottom. So what I have here is I have a pyramid that's been cut, so it's a frustum. Let's find the volume of our frustum. We'll go up to our area where we have our formulas. So I have a frustum. The frustum has a polygon bottom. Since it has a polygon bottom, it is a pyramid. So the frustum of a pyramid, I'm going to come over here. This is my volume formula. H over 3 parenthesis B1 plus B2 plus square root of B1 times B2. H over 3 times B1 plus B2 square root of B1 times B2, and I'm not 100% that's right, so I'm going to go back up, double check it. So H over 3 parenthesis B1 plus B2 plus, that is what I have. Okay, so let's think about what I have here. H is going to be the height of the frustum. So the 15 is my H. B1, since what happens when you're dealing with geometric solids is when they're capitalized, what that means is the area of the shape, versus if they're in lowercase, then it's a single line, it's linear. Since this is a capital B1, what they're asking for is the area of the base, and I have two bases. I have the top and I have the bottom. what I'm just noticing about this shape is I have that it's 12 here, 24 on the bottom. I do not know how long it is, so I'll have to add and give it an additional distance, because what's happening is on the top and the bottom, those are either rectangles or squares. I don't know which one. So the height is 15. We're going to divide that by 3. I need to find the area of base 1 and base 2. What I'm going to do is I'm going to give us some more information. Since this is 24, we'll say that this is 20. This is 12. We'll say this is 13. The shapes that you'll be given in your assignments will have all of the necessary labels on. I apologize for that. So base 1, we'll just say this is base 1. The area of this base is a 13 by 12. So it's a 13 times 12 for my base 1. Plus base 2 is a 24 by 20. Plus the square root of my 13 times 12 times 24 times 20. What you can do if you don't like all these numbers here is go ahead and do the multiplication before you write them down. 15 divided by 3 is 5. 13 times 12 is 156. 24 times 20 is 480. If I go ahead and multiply 156 times 480, I get 74,880. I'm going to go ahead and just do all of this in one fell swoop. 156 plus 480 plus the square root, 74,880. I end up with a volume of approximately 4,548.2, and those are in inches, so it's inches. Now, this one is different from the two I've done previously. Up above, I've wrapped it or labeled it. Here I'm actually filling it with concrete, for instance. So it's inches cubed because I'm filling all 3 dimensions. Volume is always cubed. In this case, I have a cylinder. Let's go back to doing the lateral area. Again, in every case, we identify the shape, and then we go find the formula that fits what we're being asked. So we identified this shape as a cylinder, and we're doing the lateral area, so it's 2 pi RH. R is the radius. H is the height. So 2 times pi times 12.1 times 9.6. This one does not have units given. That does happen sometimes. That doesn't mean we can't label it. 2 times pi times 12.1 times 9.6. So our lateral area is approximately 729.9. Since I don't know the units, I'm just going to write units, and I'm doing lateral area. So I'm doing this is exact example of the label of the soup can. So it is squared. Here I have a pyramid. Let's find the total surface area. Go ahead and go up and identify our formula. Now I'm having to scroll back and forth. It might be beneficial for you to have this chart printed out and just next to you the whole time. So on our pyramid, we're doing total surface area, so it's 1/2 PS plus B. Notice your B is capitalized. 1/2 PS plus B P is our perimeter. S is our slant height. B is capitalized. It's the area of the base. So let's see what I have. My perimeter looks like I have a square on the bottom. So 40 times 4 would be 160. So 1/2 times 160. Now my straight up and down height is 21. It is a slant height of 29. Area of my base, I have a square. To find the area of a square, it's 40 times 40. So I'm going to do 1/2 of 160, which is 80. 80 times 29, 2320, plus 40 times 40 is 1600. 2320 plus 1600, 3920. This one again does not have the units, but I'm just going to write units. It is area, so it's units squared. Last but not least, I have the sphere. We're going to go ahead and find the volume of this. So for instance, if I had a ball, it would be how much air is inside of the ball. I have a sphere. Notice it says not applicable under the lateral area. A sphere doesn't actually have just a side with a top and a bottom. It's all encompassing, so there is no lateral area for a sphere. It either has the total area or it has the volume. Our formula for the volume is 4/3 pi r cubed. R is the radius. It's 4/3. Forgot the 4 there. 4/3 pi times r is 9 and it's cubed. Again, make sure you use the pi button. It is approximately 3053.6. I'm doing volume. I'm filling the ball. So this time it is units cubed. All of the volumes will always be cubed. All of the areas will always be squared. If you have any trouble with any of the questions from your assignment, please let me know so I can give you some help. Have a good evening.